He works on the ICAP and LexiClose captioning systems, won an Emmy Award in 2014, and continues on many of the world's most watched sports and news programming channels. His topic today is a fully AI approach to descriptive video accessibility. Take it away.
Thank you. Okay, thank you. Thank you all for coming. Do we have my slides? There's no slides. Oh, perfect. That's amazing. It's so smart it didn't even need to know what I was going to talk about. It just reads the abstract. That's how all these are generated anyway, let's face it. So, who in the audience is actually knows what this is going to be about? In all seriousness, descriptive video or audio description. Do show of hands. Yeah, most people. Good. So, I mean, we'll be. Are we actually going to have the slides?
Working on the slides. Give me a couple of minutes here.
Yeah, so, descriptive video, right, it's called descriptive video or audio description, kind of, confusingly, depending on, which region of English you speak or in which country. But the basic concept here is that we're going to take a video production that would include audio, and we're going to render all of the things that, if you didn't see the vision, right, because you were blind or low vision, or just closed your eyes for a minute potentially, you wouldn't catch these details and you wouldn't understand the program. And so it's a form of accessibility service that is designed for people to be able to really continue to enjoy the program even without seeing the visuals. And so the way this will typically work is that when you have gaps in the dialogue of the program, an additional narration track is scripted in and voiced in that will tell you what's happening during these scenes with no dialogue, and, whether it's action or setting the scene or, things. So kind of basically think, what would you miss out on if you were going to be, just listening to this program? It's an interesting challenge to script this in any method. Traditionally this has been scripted by trained humans who will follow a set of guidelines for how you do the scripting, trying to understand, okay, how to best express what's happening to somebody who's listening to the program, and, catch as much as possible. And it's very challenging, right? We say a picture is worth 1,000 words, and you have 59.94 pictures per second. You have not very many words generally to be able to express what's happening in those pictures that you can add into these narration tracks. So, it's actually an interesting kind of creative task in a lot of ways for the scripters to be able to ask, what can we do in a limited gap that the dialogue of the program affords to be able to really illuminate what's happening there and what you could be missing out on. So in the recent work that my group has been doing in AI media and that we'll be presenting here, we've been looking at, can we use a combination of AI techniques to speed up or even replace completely the human-based process of doing AD. So we're going to do the scripting based on using video processing large language models in order to generate a summary of what's happening during these segments. And we're going to use other AI and AI adjacent technologies like speech-to-text transcription to understand what's happening in the dialogue of the program, so that during you know what the context is, because one of the most important challenges then is going to be moving beyond what you just have from describing what's in the picture to actually moving on to saying, how does this impact the story? Because ultimately what we're trying to do here is storytelling. And so that is an interesting challenge for an AI system, which, an LLM can be very good at following prompts and following the rules of, describe things like this. You might give it instructions like, focus more on these details, focus less on these types of details. Ultimately, you also need it to form a correct narrative. We might have slides. I have some slides on the monitor. We also have a demo video that shows a highlight reel of some of the clips that have been generated by our process and what's possible with these type of AI systems right now. And we will analyze a scoring methodology that we've developed in-house to try and describe the quality of the AI generated from this process to try and iterate on and improve on that. Because there is also, while there is beautiful. So you've already gotten the summary of a lot of this. We know what descriptive audio or video description is. It's relevant to a lot of people because also there's a growing regulatory demand for this in a lot of markets. There's a small regulatory quota already on major broadcasters and cable channels in the US. There are somewhat larger quotas in some countries like Australia, Canada, the UK. And in a lot of countries, there's a consideration of potentially increasing the amount of audio description that needs to be delivered. Mandating it across more platforms. It can, in very general regulations like European Accessibility Act or Americans with Disabilities, could be seen to regulate this in a lot of environments. One of the problems is that it is just very expensive to do, and it's very time consuming to do, and that can help prevent more people from doing it on more content. So our goal here is both from the perspective of the content producer to cut the cost, to cut the turnaround time. From the perspective of the audience, we believe this leads to a greater volume of material that's being produced because it becomes more affordable to do so. So we've kind of already gone through the basic methods here, but basically it's going to be a combination of AI approaches, and you can see here kind of a simplified block diagram of what our software process looks like. So we're going to be starting with something that looks basically what is the content of this program, right? And we're going to use a broad video summarization from video understanding LLMs. We're going to do transcription of the dialogue, summarization of that dialogue, and we can also do face recognition, which is important for recognizing the characters, because you'll see that that's going to be a major distinction when you ask to describe the video between essentially descriptions that say, there is a man wearing black, and, Bruce Wayne has arrived. Who is the man? And some of that may be almost impossible for any automatic system to recognize unless it's been exposed to some kind of basic content-specific pre-training. How do I recognize the characters in this program? What do they look like? What are their habitual costumes? Things like that are going to be important to go beyond, surface-level description that this is a man in a suit. We're then going to look for places to insert descriptive elements. That's going to be important because in a traditional, linear watch program, you can only insert descriptive elements when there's a gap in the dialogue. You don't want to talk over the dialogue with the description. In some content types, that leaves very little room for description. That can be a challenge. Basically, you address that the best you can in this method. There were alternate practices that can address that in different ways that are non-linear, like effectively making a companion narration track that could be watched, while a video is paused or separately to understand more content. A lot of times that's called extended audio description. That hasn't really been the focus of the work so far. So we're going to segment into gaps in the dialogue where we can put a description. We're going to know effectively the timing of those gaps, which defines how much much description you can put in them. And then we're going to process the surrounding media to understand what's most relevant to put in the time provided. And if we have more time, we can describe in more detail the different action that's being seen. If we have less time, we're going to have to resort to really only the single most important sentence that can be said about what's been occurring on screen. Finally, we'll voice that and we'll create a final mixed track. So this is looking at the ability to do an entire AI workflow where, what's going to pop out on the other side is the video with a new audio track that includes the descriptions. In realistic workflows, sometimes you may want an incremental piece ahead of that, which would be something like, a track that only contained the audio for the descriptions that could be mixed at a later time, or could even be dynamically mixed with audio metadata. You may want to hire your own human voice actor to voice a pre-existing script. You may want to edit the script. So there were a lot of let's say exit ramps for where additional processing could be done, but these examples are fully automatic examples that we'll be showing in a moment. So the facial recognition is the only example that's in these videos where we've actually done manual processing. And in that case, what we've done is we've pulled out the major character images from the video that we've come in, and we've had those be labeled as what is the name of this character. I believe in theory, in a lot of cases, it will be possible to do this part automatically too. You can, as long as the character is addressed by someone somewhere in the program. I mean, how do we know when we watch a program what any of the characters' names are? You often don't know the first time they appear on screen. You learn it as part of, the dialogue unfolds. It's possible, I believe, to automate that as well. In this case, we did some manual tagging. So as then we'll do we'll make the individual segment descriptions. And I think we're ready at this point to show the video demo. We'll see if this hopefully plays out. Yeah. All right.
A holographic brain float.
Except this is not the right audio.
Is this freaky?
In a dimly lit bell tower, Barley crouches with a sniper rifle. Through his scope, an aerial machine with bright lights hovers.
Shouldn't you be down there?
In a dimly lit room with candles, Barley aims a rifle from the balcony as Tom, in pain, rises clutching his shoulder.
I heard you guys talking last night.
On a sunny day, Tom materializes from a digital grid near a canal, inspecting an object in his hand while walking along the cobblestone path. Tom walks along a canal in a picturesque city, wearing a jacket with a yellow wolf design. He stops to observe a large, detailed robot up close. The captain urgently speaks into a handheld radio.
And action!
Why don't you just admit that you're freaked out by my robot hand?
On a bridge, Celia lifts her robotic hand. Pink text appears.
This is Celia. I was young.
Barley, a soldier, surveys a battlefield as giant robots advance. He falls, and a clock tower crumbles. Inside, an engineer manipulates the complex device. In a damaged cathedral overrun with plants, 4 people in white suits fire energy weapons at approaching mechanical beasts. Barley fights and hangs onto a rope. On a bridge by the canal, Tom faces a large mechanical robot, wires and gears exposed.
The world's changed, Celia.
So, that's kind of shows what we're capable of doing at this point. I mean, you can see that that's probably from about a 10-minute video. It's been compressed right into about 2 minutes that show where there's actual, opportunities for descriptions. Some of the sections are more talky and have a lot less dense description. So, it works throughout the extent of one of these videos, but sometimes in a lot of programs, we've done things, for example, instructional videos or something where the density of the speaking can really do a lot for whether something is good for demonstrating the capabilities of the automatic audio description or not. When something has very few opportunities to actually put in a description, it doesn't really show whether the description works or not, of course. So to zero in on a couple of these and what are some of the challenges, what it does well, and what it doesn't. From this example, you see they have the man lies on the blanket. He sits up wincing. I think this screenshot is actually from a version that didn't have the facial recognition put in. So he's described as Tom in the video you saw. Here it says the man. But basically you see it has a foreground and a background element, and it's actually pretty well able to describe, there's two people in the same scene. It kind of balances between a description of, the shooting man and, the man lying on the blanket. It moves from one to the other as the camera focus pans. So, that's an example of how we're able to follow the story of that small segment, I think, very effectively. Here you have an example, this is a very important one for actually identifying the characters, and especially, in this particular clip, we have the character who sort of morphs between being a woman and a robot, or you have the clip where the man materializes out of the grid. These are kind of confusing plot aspects. They're not even really, I think, fully understood, to the typical viewer of the film, but the AI is actually able to relatively accurately describe what it sees on screen. And one of the things you'll usually try to do as a guideline for any kind of AD scripting is to try and describe what you see on screen that's kind of obvious and apparent without over-explaining. The goal isn't really to explain plot elements or something in a way that a viewer who is encountering the program for the first time seeing it wouldn't pick up on, wouldn't know, or wouldn't understand. If it's a mystery how this happens, then you're not really supposed to give away the mystery in your scripting. So that becomes another challenge that we deal with when trying to manage the scripting automatically. Here's an example of one from a different clip. This is an example of the kind of thing that, doesn't always go right. I mean, this character is, it's a beaver in this. I think it's intended to be a dog, we actually ran through this clip on a bunch of different iterations. It has a bunch of animals. None of the animals really look very much like, real animals. They're cartoons, and the interpretation of what it is that will pop out of a Gemini or a GPT, it's surprising how much it varies. Sometimes it sees a dog, sometimes it sees a rabbit, sometimes it sees a beaver. It's an example of where even with a cartoon animal that doesn't really have a face, you might need facial recognition to just understand what animal do the creators intend this to be. Let's know that. Let's stick with it. Let's not try to guess. So we went through and did evaluations on a lot of content, and we kind of found that there wasn't a lot of quality research out there in terms of describing, in a holistic sense, whether an AD performance was good or bad. You can watch it, you can say, does it follow our house style guidelines? Does it tell the story well? But on the other hand, there's a lot of aspects of good and bad, and it's not actually as straightforward as something like grading a caption transcription, So we were informed by approaches that AI media uses, like the NER system, in grading subtitle accuracy, but it's quite a bit more multidimensional than subtitle accuracy. So we looked at things like, does it correctly identify where there should be descriptions and where there shouldn't be? Does it write the basics, right? Does it write sentences that are coherent, grammatically correct, use sensible word choice? Is it factual, or does it hallucinate and say that it saw things that aren't in the image? Then even if the description is factual, is the description well focused? Does it focus on a detail that isn't very important and miss something that's actually more important? And how is the continuity and the storytelling? Does it, if I'm the main character of the movie and every time I walk on screen, it just kind of describes my haircut over and over again, well, that's not new information, after the first time. It's like, that's not actually a good description. You don't want to say the same things again and again. You need to focus on novelty in order to kind of tell the story and give a full picture and keep things moving. So all of these things, we try to give this a linear set of weights. I'm frankly not entirely satisfied with that approach, because in a sense, if some of these things are all wrong, then it doesn't really, it doesn't make sense to be 87% correct on this. But if none of it is intelligible and it all overlaps with the dialogue, clearly 87% kind of overstates how useful it really is. But, there are a lot of different elements. So any weighting system needs to weigh the fact that a system could produce results that are quite good in one respect while being terrible in other respects, So we saw that we really had, in the current systems that we've developed, very few problems with the narration being produced, being, intelligible, well written according to the style guidelines, basically factual, fitting within the space allotted for it. Essentially, it meets the requirements we ask it to meet when those requirements are really clear and are encapsulated within any single piece of description. In some issues we found, mild hallucination or factual errors issues, but even that was fairly rare. Most of the descriptions were highly factual. Most of them didn't describe things that weren't there. Even in cases where there's maybe a mild hallucination, like in that example, it talks about the jacket having a yellow wolf. I'm not sure I actually see a wolf in that jacket. I see more of a swirly pattern, but it's yellow. I don't even know. It could be a wolf. I wouldn't call that a severe error, but it's an example of the sort of thing that happens. What wasn't always so good was really consistent identification of the same person, object, or place over the course of a program, like making sure that each time we describe a man in a suit jacket or a suburban house, it's like, how many houses have appeared in this movie? How many men in suit jackets? Is this all one character, or is this a different character in each occurrence? Issues like that often weren't really clearly, we need to work on making sure we grab the context well enough on this, that we're identifying that, actually you're seeing the same setting, the same person, the same object that's been relevant in a past scene, even understanding that as people, what you could call our context windows are quite deep. And some shows take a lot of advantage of that. Some shows expect you to remember really complicated plot points that might have happened 2 episodes ago. And, that's going to be a challenge. We also found that, using kind of basically off-the-shelf models, from Gemini, from OpenAI, we were seeing that to a greater or lesser extent, depending on what settings you use. But there's a lot of concern, right, about AI safety and, what AIs will and won't chat to you about and answer questions about, and, how they describe things. And we found that, given that the content on TV, as we've all been warned many times, is like very violent and very bad for your emotional health, a lot of the content that's on TV all the time, that's commonplace and accepted, predicted, is things that these models appear to shy away from wanting to describe and discuss. And in many videos we fed it, we noticed a tendency to kind of produce descriptions that were sanitized, that were removed of elements that could be viewed as politically or socially sensitive, even when those elements were just critical to understanding the programming. So to some extent, that may just mean that to get a better result on this, you need to use models that are a little bit more unlocked from the standpoint of content filtering, but that also could be something, even things like copyright will be a problem with this. The model actually doesn't want to make up stories about Batman that aren't licensed by the owners of Batman. However, if you are, working on legitimate Batman content and you need descriptions about Batman, that's going to present a challenge for you. So some of these things, I think, further work and kind of more dedicated research that goes farther beyond kind of off-the-shelf available models can probably solve a lot of these problems. But to date, it's something that certainly has appeared to be a challenge for us. And I think in summary, there's a lot more that can be done here. I think the systems are, no doubt going to continue to get better, both kind of due to general uplift in what AI video processing models are capable of, as well as, the research that in our team, and I'm sure in some other places, is being done to suit that specifically for this kind of task. We also need to find out where we're landing in practical workflows between human assistance and human checking and human revision. And, is this something where either you're going to do all humans or all AI, or is this something where the sensible medium-term outlook might have some balance, where you might say, we're going to use AI tools to accelerate certain aspects of this production. We're not just going to push it into an AI model, however, and just air whatever pops out, So how to get that balance and how to deal with the fact that, in some of these services, injecting any level of kind of human editing tends to bring back a lot of the same costs and time pressures very rapidly, even when you only need them to edit 1 out of 50 things. It's kind of like, well, if they still need to read all 50 of the descriptions and understand the whole program in order to find the one description that they're going to manually edit, it's more expensive than it seems like. So, making 98% great descriptions and 2% awful descriptions, unfortunately, maybe that sounds really cool, but maybe less useful than it sounds until you're at an even higher percentage than that. So thank you. Happy to take questions as time allows.
All right. Any questions from the audience? Right over here.
Could you talk about the latency of creating the content, and does 2-pass improve the accuracy? And have you tried real time at all?
Since we do a lot of real time with captions and translations, we've certainly been interested in looking at real time. We haven't tried this process with real time yet. I think real time description can often be a pretty different beast in general. I would say I don't know that much about that yet. The throughput of what we've currently done, or the latency for something that's pre-recorded, I would classify for most purposes as pretty excellent. I think we can pass something through this at maybe 1x real runtime, so it runs fast from a pre-recorded standpoint, but whether we would be able to do what we needed to do from a real-time standpoint to understand the video well enough is a little bit of a question, because of course you have to make very sharp decisions about when to describe and how much to say without overlapping what something like, if you imagine, say, a sports game, like what an announcer is going to chime in and say. And of course, there are providers of live descriptions now, but it's really, I would say it's its own specialty in a way, because already something like a sports match has announcers who are striving to describe beyond field action and are not necessarily leaving a ton of extra space in stuff that's unsaid. And we've looked a lot into whether we need different models on this and different frameworks for just different genres of content, even in the recorded space.
Yeah, Rick Ackerman, CBS Television. You talked about the amount of time necessary for humans to intervene, but you do have problems where sometimes you have sporting events with strange nicknames that teams have. If you're doing something like that, where if somebody doesn't actually enter it into the engine, it's not going to get it, or it could say something, misinterpret it and say something really nasty on air. So I do think for a lot of this stuff, you need some kind of a hybrid approach where a human being can interact with the system and tell it the sorts of things it needs to know. Possibly a movie where a character isn't revealed till halfway through the movie. You don't want it revealing the character in the very first scene, and the AI might not know that don't describe this character by name until an hour and 15 minutes into the movie. And those are types of things that there needs to be a very simple interface where a human being can get in there and deal with the AI engine to make it work better.
Yeah, I mean, hopefully not forever. I mean, certainly when systems don't work well, someone needs to intervene, and that's a big problem. I think in an example like, not revealing secrets beforehand, that's something that's kind of handleable with a general rule or directive, which hopefully, I'm relatively confident the models can accurately follow. You say like, well, if you just think of it as a simple TP kind of prompt, tell me what's going to happen here. Don't use information that's from some other future thing that I want you to pretend you haven't seen. But, yeah, I mean.
Yeah, like we had one situation in a very high profile event earlier this year where due to a technical issue, we had to put briefly AI captions on air. And we were sitting there in the executive room just sweating bullets, terrified that during this very brief period, it was going to say the wrong thing. And it would have been really bad for our careers, to put it mildly.
Been living that life for years, man.